Hello, today we're going to talk about endothermic and exothermic processes. So let's review endo and exothermic really quick. You always want to define your system and your surroundings. For the most part in chemistry, the system is the particles that are reacting, or it could be the particles undergoing a phase change. And if the system is losing energy to the surroundings, that's exothermic. But if the system is gaining energy from the surroundings, that's endothermic. Now be careful because a lot of times when you have a water-based system, the water is part of the surroundings. Okay. Same idea when we're taking the temperature. The temperature is typically measuring the surroundings. So if you have an exothermic process, then the temperature will appear to increase because the system is giving off heat, which the thermometer picks up. Same idea with endothermic. If it is absorbing energy from the surroundings, the temperature of the surroundings will decrease, so we'll observe a temperature change, a temperature decrease. Okay, so what is heat? Heat is the energy that's transferred due to a temperature difference. So if we keep it really simple right now, you have something at a higher temperature versus a lower temperature. So temperature, remember, measures average kinetic energy. So the one with the higher temperature has more kinetic energy. The energy then will transfer from the higher temperature to the lower temperature, and that energy that's transferred is the heat. And so heat is a type of energy, thermal energy, and it's measured in joules is the SI unit. Sometimes we'll use kilojoules. The letter that we use for heat is Q, and it can be positive when it's endothermic or negative when it's exothermic, although sometimes we just refer to heat in terms of the magnitude. So if we say it's releasing 20 joules of heat, well, that would be a negative change because it's releasing, but you don't have to say, or you shouldn't say, releasing negative 20 joules because that's kind of like a double negative. So just be careful with your wording there. Okay, so let's look at this example. Instant coffee is made through a process called freeze drying. First, the coffee is made in the traditional way, then it's cooled down until it becomes a solid, and the pressure is decreased and the ice changes to a gas, leaving behind the freeze-dried coffee granules. So we want to identify two phase changes that take place and classify them as endothermic or exothermic. So one of the phase changes is that the coffee is going from a liquid to a solid, and in order for it to do that, it has to get rid of some of its energy. It gives it off to the surroundings. It's not disappearing. But when the coffee goes from a liquid to a solid, that is an exothermic process. All right, so that's one of them. And then the water that was present in the liquid coffee is going to change from a solid, so the water is going to change from solid ice into a gas by rapidly decreasing the pressure. So when it does that, that is sublimation, and it must gain energy, so that must be endothermic. Let's look at this next example. A solution of ammonium nitrate was created by dissolving 5.02 grams of ammonium nitrate in 100 milliliters of water at 22.3 degrees Celsius. After forming the solution, the temperature was 17.3. Did heat enter the system or leave the system? So heat entered the system. Because the water was 22.3 degrees Celsius, now the water was 17.3 degrees Celsius, the energy was leaving the water and going into the system. So Q must be positive for that process, which makes it endothermic. You just need to really be careful because you're measuring the temperature of the surroundings. Right? You can't measure the individual ammonium nitrate particles as they're interacting with the water molecules. It's not possible. So we're measuring the surroundings, and since the surroundings decreased in temperature, the surroundings are losing the heat. The system must be gaining the heat. So just be careful with that.